Welcome my dear learners for this course on design of machine elements 2. In this module 2, we are discussing on design of springs, design of belt drives, rope drives and chain drives. In our previous lecture, we have started our discussion on design of flat belt drives. So continuing our discussion, the problem number 2 of our discussion on design of flat belt drive states that a flat leather belt drive is used to transmit 15 kilowatt power at 1400 rpm to a big pulley rotating at 480 rpm. The center distance between the pulleys is twice the diameter of the big pulley. The belt should operate at a velocity of 20 meters per second and stresses in the belt should not exceed 2.25 megapascals. The density of leather belt is 0.95 gram per cc and coefficient of friction is 0.35. The thickness of belt is 5 millimeters. Calculate diameter of the pulleys, the length and width of belt and belt tensions. So let us solve this problem. So if I list out the data given for problem number 2 and analyze the data, we have a flat leather belt drive is used to transmit. We have specified the power as 15 kilowatts and the speed N1 is stated as 1400 rpm. To a big pulley rotating at N2 is 480 rpm. The center distance between the pulleys is twice the diameter of the big pulley. So center distance is 2 times diameter of big pulley. The belt should operate at a velocity of 20 meters per second and stresses in the belt should not exceed 2.25 megapascal. So therefore design stress, that is sigma 1, is 2.25 megapascals. The density of leather belt is specified as 0.95 gram per cc, which means 0.95. I will raise 10 to the power of minus 3 to convert this into kg, and cc stands for cubic centimeter. So therefore 10 to the power of minus 2 whole cube will gives us this in kg per meter cube. So therefore density will become 10 to the power of minus 6. Taking it to numerator, it will become 10 to the power of plus 6. Plus 6 minus 3 is plus 3. So therefore finally I get 950 kg per meter cube. Next, we have the coefficient of friction is 0.35. Mu is specified as 0.35. The thickness of the belt is 5 millimeters. Very important. He has specified the thickness of the belt. So therefore, while calculating velocity, I should consider thickness of the belt. He is asking to find the diameter of the smaller pulley and bigger pulley, length of the belt, width of the belt, and belt tensions, that is T1 and T2. Let us solve this problem. If I move for solution, so first let us make use of velocity equation and find the effective diameter of the smaller pulley, that is diameter of the prime mover. So since he has given the velocity v, I can write this as pi d plus p into n1 divided by 60,000. This is because thickness is specified. So therefore I should consider the thickness without fail. I have considered velocity is 20 meters per second, pi times diameter is unknown, thickness is pi mm, rpm is 1400 divided by 60,000. So therefore diameter of the prime mover will be, the answer is turning out to be 267.84 mm. So now we have to find another pulley. We know that velocity is constant. Therefore I can write d n1 must be equal to capital D n2. So if we consider thickness, it doesn't make any difference. So therefore Here I am not taking the thickness into account. If I solve, I will get 267.84 into 1400 rpm must be equal to diameter of the bigger pulley, which is rotating at 480 rpm. So therefore I will get diameter of the bigger pulley as the answer is turning out to be 781.19 millimeters. So we have calculated the diameter of prime mover and also the diameter of the larger pulley. So now he himself is stating that the center distance is 2 times the diameter of larger pulley. So therefore center distance will become 2 times the diameter of larger pulley, which is nothing but 1562.38 millimeters. Next, moving to calculate the length. Length of belt is given by L is equal to 4c square minus d whole square under the root plus half of d theta L plus d times theta S. This is equation 14.2b. So this is equation 14.2b, referring to page number 291. So where theta L and theta S are specified in page number 290. So we know that theta S is equal to pi minus 2 times sin inverse of d minus d by 2c, and theta L is pi plus 2 times sin inverse of d minus d by 2c. So the answers will be, very important note here is to be, your calculator must be in radian mode whenever you calculate theta S and theta N using this formula. So therefore first I will set up the calculator in radian mode. So therefore I will get pi minus 2 into sin inverse of capital D is 781.19 minus small d is 267.84 divided by 2 times C. C is 1562.38. So if I solve, I will get theta S as 2.8115 radians. So similarly, if I solve for theta L will be, so theta L is turning out to be 3.472 radians. So very important note is that your calculator should be in radian mode. These two equations are available in page number 290, equation 14.1a, equation 14.1b. So next, moving for calculating length. So if I substitute in the length equation, that is 14.2b, and solve, I will get the length as, all the values. If I substitute and solve, we will get square root of 4 times C is 1562.38 square minus capital D is 781.9 minus small d is 267.84 whole square plus 0.5 into capital D is 781.19 into theta L is 3.472 plus small d is 267.84 into theta S is 2.8115. So therefore I'll get the length of belt as 4814.85 millimeters. Next, once we're done with length, we want to determine the value of width. So coming for calculation of width, directly we can use power equation. We have power equation given by BTV by 1000 into sigma D minus sigma C into 1 minus 1 by e to the power of mu theta. Since coefficient of friction is same for both the pulleys, e to the power of mu theta is nothing but e to the power of mu theta S. So therefore e to the power of mu theta is e to the power of mu theta S. So we know all the values. If I substitute and solve, I will get the answer. So therefore, since mu is same for both the pulley, e to the power of mu theta is nothing but e to the power of mu theta S. And we want to calculate the value of centrifugal stress. The formula for centrifugal stress when density is given is rho v square. So I specified the density as 950 kg per meter cube. Velocity is 20 meters per second square. So therefore, if I solve, I will get the answer as 0.38 megapascals. That is 0.38 into 10 to the power of 6 pascals, which can be treated as 0.38 megapascals. So we know all the values. If I substitute and solve, I will get the answer as power is 15 kilowatts. So therefore 15 is equal to B into T is area, velocity is 20 divided by 1000 times direct stress. So design stress should not exceed 2.25 minus 0.38 into 1 minus 1 by e to the power of mu is 0.35 into theta small is 2.8115. So theta is nothing but theta S. So if I solve, I will get the answer for area as area is equal to 640.485 millimeter square. So now area is width into thickness. Thickness is 5 millimeters. So therefore, if I divide it by 5, I will get the width as B is equal to A by thickness, which is turning out to be 128.097 millimeters. So width of the belt is 128.097 millimeters. We can adopt 130 mm width, 5 mm thick belt for the desired operating conditions. So we have determined length and width. Finally, I want to calculate the belt tensions. Belt tensions are T1 and T2. So coming for calculating the belt tensions, we know that tension T1 is sigma D into area. So therefore, tension in tight side will be sigma D is given 2.25, area is 640.485. So therefore, tension in tight side will be 2.25 times 640.485, which is nothing but 1441 newtons. And coming for tension in slack side, it is calculated based on calculation of sigma 2. So to calculate sigma 2, equation 14.3d, which states that sigma 1 minus sigma c by sigma 2 minus sigma c is equal to e to the power of mu theta. So I know all the values. If I solve, I will get sigma 2 as sigma 1 is 2.25 minus sigma c is 0.38 divided by alpha x minus 0.38. This must be equal to e to the power of mu is 0.35 given. So theta is theta s. Theta s is known for us, which is 2.8115. So if I solve, I will get the value of sigma 2 as 1.08 megapascals. So therefore, tension in slack side is sigma 2 into area. So sigma 2 is 1.08 and area is specified as 640.485. So therefore, tension in slack side is 691 newtons. So this is the complete solution for problem number 2, wherein which we have calculated the diameters of smaller and larger pulley, length, cross-sectional area required, and width, and finally we have calculated tensions. Tension in tight side is 1441 newton, tension in slack side is 691 newtons. Let me pause this video for a while so that people can copy it down. Later we will solve problem number 3. Next, moving ahead, the problem number 3 states that a flat belt is required to transmit 10 kilowatt from a pulley of 600 mm effective diameter running at 300 rpm. The angle of contact is spread over 7/16 of circumference. Determine the width of belt whose thickness is 10 mm. The allowable stress for the belt is 2.25 Newton per millimeter square. Coefficient of friction is 0.3. So if I list out the data given for problem number 3 and analyze, I will get the flat belt is required to transmit a power of 10 kilowatts from a pulley of diameter 600 mm, which is running at a speed n1 is 300 rpm. The angle of contact theta is equal to 17/16 of circumference. So he is not stating it as circumferential length, it is 7/16 of circumference. So therefore it is 7/16 of 2 pi radians. So therefore theta will be 7/16 of circumference is 2 times pi, which is nothing but 2.749 radians. Determine the width of the belt. Belt width is not known. He has specified the thickness as 10 mm and allowable stress for the belt. So design stress is 2.25 megapascals. And also the coefficient of friction mu is given as 0.3. So whenever the parameter pertaining to cross-sectional area is asked, always we should use power equation. So go for power equation. We know that equation for power P is given by width into thickness into V by 1000 times sigma d minus sigma c times 1 minus 1 by e to the power of mu theta. This is nothing but 14.5 a. Referring to page 291 of our design data handbook. So here the unknowns are area, centrifugal stress and e power mu theta. Let us calculate one by one. Centrifugal stress is given by Wb square by 10 to the power of 6g. So since specific weight is not given, so for leather we have, for leather belts specific weight W is 10 to the power of 4 Newton per meter cube. So therefore sigma c will be 10 to the power of 4 into velocity is also unknown. So therefore let me calculate velocity first. Velocity v is equal to pi times d plus thickness, because thickness is specified, into n1 by 60,000. So since thickness is specified, we must consider the thickness and solve. So diameter is 600, thickness is 10 mm, into speed is 300 divided by 60,000. Velocity is found to be 9.582 meters per second. So therefore sigma c will be 10 to the power of 4 times 9.582 square divided by 10 to the power of 6 into 9.81. So this specific weight of leather should be known to you people. Whenever he has not given, you should take the specific weight of leather as 10 to the power of 4 Newton per meter cube. So if I solve for centrifugal stress, the centrifugal stress is turning out to be 0.094 megapascals. So we have found out all the values. So therefore, if I solve, so we are not calculated e power mu theta. Let us calculate e power mu theta also. E power mu theta will become, mu is 0.3 and theta is 7 by 16th of circumference. 7 by 16th of 2 pi is 2.749 radians. So therefore I'll get the capacity e power mu theta as 2.2812. So now if I substitute the power equation and solve, I'll get the cross sectional area as B into T is area, velocity is 9.582 divided by 1000 times design stress is specified for us, which is 2.25 megapascals, minus sigma c is 0.094 times 1 minus 1 by e to the power of mu theta is 2.2812. So if I solve, the cross section area of the belt is, cross section area is turning out to be 861.87 millimeter square. So therefore width is equal to cross section area by thickness. So thickness is 10 millimeters. So therefore we'll get the answer as 86.187 mm. So therefore adopt width of 90 mm. So adopt a leather belt of cross section area 90 mm cross 10 mm for the given specifications or for the given details. So this is solution for problem number 3. Let me pause this video for a while so that people can copy it down. Later we will solve the final problem of this lecture, which is the complete design of flat belt drive. Now moving ahead for the final problem, which states that design a belt drive to transmit 25 kilowatt from a motor shaft running at 1500 rpm to a compressor running at 500 rpm. The motor pulley is 96 mm effective diameter and the center distance between the shafts is 1.5 meters. So let us design this belt completely, which was asked in the V2 examination. So if I list out the data given for problem number 4, we have the power to be transmitted as 25 kilowatts from a motor running at the prime mover driver N1 is 1500 rpm to a compressor N2 is 500 rpm. The motor, there is a prime mover, diameter is given, small d is 96 mm. The center distance is also specified, which is 1.5 meters, which is nothing but 1500 millimeters. So let us solve this problem. In first step, find the diameter of compressor. So dia of compressor will be, we know that D times N1 must be equal to capital D times N2. So effective diameter of motor is known, which is 96 millimeters running at a speed of 1500 rpm. Diameter of compressor is unknown, whereas the speed of compressor is 500. So therefore we get the diameter of the compressor as 96 into 1500 divided by 500, which is nothing but 288 millimeters. Next, in step 2, calculate the velocity. Since the belt thickness is not known to us, we should not consider the belt thickness. So therefore V is equal to pi d N1 by 60,000. So if I solve, I will get the velocity as pi times d is 96, N1 is 1500 divided by 60,000, which is turning out to be 7.54 meters per second. 7.54 meters per second. So next, let us calculate the value of centrifugal stress. We know that centrifugal stress is given by Wv square by 10 to the power of 6 into G. This is 14.3 F, referring to page number 291, where W for flat belt. So we know that W for leather belt is W is 10 to the power of 4 Newton per meter cube. So therefore the centrifugal tension is 10 to the power of 4 into velocity is 7.54 square divided by 10 to the power of 6 into 9.81. So if I solve, I will get the centrifugal stress as 0.06 megapascals. Now moving for fourth step, to calculate capacity. We know that the capacity is given by e to the power of mu theta. So first step is I should find the value of mu. So the equation for mu is given by 0.54 minus 0.712 by 2.542 plus b. So this is equation 14.3d, page number 290. So So if I substitute and solve, I'll get the coefficient of friction as 0.54 minus 0.712 divided by 2.542 plus velocity is 7.54, which is nothing but 0.469. 0.469 is the coefficient of friction. So now let us calculate both theta s and theta l. Theta s is equal to pi minus 2 times sin inverse of d minus d by 2c. This is equation 14.1a. A very important note is that your calculator should be in radian mode while solving. So first I will convert it into radian mode. Now if I calculate pi minus 2 into sin inverse of capital D is 288, small d is 96, divided by 2 times center distance is 1500. If I solve, I will get theta s as 3.014 radians. 3.014 radians, whereas theta larger pulley is given by pi plus 2 times sin inverse of d minus d by 2c. This is equation 14.1b. So we get the value of theta l as, just change the sign to plus. Make a note, your calculator should be in radian mode. So angle of contact for larger pulley is 3.27 radians. So superscript C stands for radians. So now I can find the capacity as, here theta is nothing but theta of smaller pulley. Theta is equal to theta s for same coefficient of friction or for constant coefficient of friction. So therefore capacity e power mu theta is nothing but e to the power of mu theta s is turning out to be, coefficient of friction is 0.469, theta s is 3.014, which is 4.11. So capacity is 4.11. Next, moving for step 5, let us calculate the constant K. We know that K is equal to 1 minus 1 by e to the power of mu theta. So it is 1 minus 1 by answer, which is 0.757. Next, moving for step 6, to find length. So you know equation for length of belt, which is given by L is equal to square root of 4c square minus d minus d whole square plus 1 by 2 times d times theta l plus small d times theta s. This is equation 14.2b, page number 291. So we know all the values. If I substitute and solve, I'll get the value of length as root of 4 into 1500 square minus 288 minus 96 whole square plus 0.5 times capital D is 288 into theta L is 3.27 plus small d is 96, theta small is 3.014. So length is turning out to be 3609.4 mm. So next, coming for calculation of cross-sectional area, we should use power equation. We know that power equation is given by BTB by 1000 times sigma design minus sigma c into 1 minus 1 by e to the power of mu theta. This is equation 14.3f. Sorry, this is equation 14.5a. 14.5a, page number 291. So we know all the values. So we know power as 25 kilowatts. B into T is cross section area. Let me take it as x, alpha x, into velocity is known. Velocity is 7.54 divided by 1000 into design stress. So design stress is given below this equation itself, which is 2.06 for leather, minus sigma c is 0.06 into the term 1 minus 1 by e to the power of mu theta is constant, which is 0.757. If I solve, I will get the answer for cross section area as, that is cross section area A, which is B into T, which is nothing but 2190 millimeter square. Now sigma D is 2.06 MPa for leather, which is given in this equation itself. So next, moving for final step to find initial tension. So initial tension equation is 2 root T naught is equal to root T1 plus root T2, which is equation number 14.8. So this is equation 14.8, page number 291. So now we know the value of T1. T1 is sigma D times the area. Sigma D is 2.06 times the area is 2190, which is 4511.4 newtons. Now make use of ratios of belt tension equation to find sigma 2, then find T2. That is sigma 1 minus sigma c by sigma 2 minus sigma c is equal to e to the power of mu theta. So find the value of sigma 2. Sigma 2 will be, sigma 1 is 2.06 minus sigma c is 0.06 divided by alpha x minus 0.06, which is equal to e to the power of mu theta is 4.11. If I solve, I will get sigma 2 as 0.55 megapascals. So therefore, I can find the value of T2. T2 is sigma 2 times area. Area is 2190. So T2 is 1197.1 newtons. So we know T1, T2. So therefore, initial tension T naught is root of T1 4511.4 plus root of T2 1197.1 divided by 2. So 50.88 is root of T naught. So square of this is T naught, that is 2589.1. 2589.1 newtons is the initial tension of the belt. So this is the complete design of flat belt drive. So by this we have completed our discussion on design of flat belt drives. From next lecture, we will be starting our discussion on design of wheel belt. That's all from this lecture. Thank you all.